video, I'm going to give you an overview of this microbial nitrogen-fixing biofertilizer model in Koi. Going to walk you through just how to navigate the model and a few interesting tidbits. Okay, so I'm starting here on the executive summary page of the model, and this is the first place that you'll land when you navigate to a Koi model. This gives us a really high-level view of the avoided emissions forecast. So on the left-hand side, we have the annual impact. So there's about 12 megatons of CO2 equivalent that are avoided in 2035 when we apply this solution technology. This is the key result from the Koi model. This number, this annual impact, is calculated based on a unit impact multiplied by the solution scale. So the unit impact is really the GHG intensity difference between a baseline and a solution. In this model, down here, you can see this little description of what the unit impact is really telling you. So in this case, it's the difference in emissions between synthetic nitrogen fertilizer, which is our conventional baseline, and microbially enhanced nitrogen fertilization, which is our solution. And so this kind of represents how much emissions can be avoided when the solution displaces the baseline. The solution scale is what it sounds like. It's how much can this technology scale over time. So in this case, the solution scale is around 100 million hectares of cropland in 2035, and that's calculated based on the total market size, which is 2,000 million hectares of cropland, and the technology's market capture, which in this case is modeled as 5%, which you can see down here. Okay, so this is the executive summary page. We can also scroll down and there's a little more info. So there's some dynamic plots of how these values change over time, as well as the description of the technology's impact and kind of some summary items of how the solution has been modeled. So the unit impact scenario and the solution scale scenario. Okay. So if I scroll back up here and want to get a bit more info, I can click into either the unit impact or the solution scale to understand more how those have been calculated. So I'm going to go ahead and click into the unit impact. And when I do that, I end up on this unit impact tab at the top. So the unit impact is really all about the GHG intensities of the baseline and then solution. And so on this page, we get a lot more detailed information about how that's working in the model. So at the top, again, we just have the unit impact value. And now if we scroll down just a little bit so we can see all this, on the left-hand side, we have our baseline scenario. So in this model, it's synthetic nitrogen fertilizer. And on our right-hand side, we have the solution scenario. And in this model, that's microbially enhanced nitrogen fertilization. So now what we see is the actual GHG intensity of synthetic nitrogen fertilizer compared to our solution technology. And we get the top level number, so the total GHG intensity here. And then we also get the GHG intensity broken down into value chain components. And that's one interesting tidbit about this fertilizer model, is that there are substantial emissions just from manufacturing synthetic nitrogen fertilizers. So if I hover over this, I can see that it's around 0.2 of the total 0.6 megatons of CO2 equivalents per million hectares of cropland. Another substantial source of emissions for the use of synthetic nitrogen fertilizers actually comes during application. And so this bar here that I'm now hovering over is direct N2O soil emissions. So when you apply nitrogen fertilizers, some of that nitrogen actually gets converted to N2O and released back to the atmosphere. And N2O is a strong greenhouse gas. And so you get this kind of chunk of GHG emissions actually from those N2O emissions during application. Okay, so now if we want to look a bit more at how the solution scenario has been put together, we can actually pop out this little sidebar. It gives us some options for selecting baseline scenarios and solution scenarios. And I'm going to just expand this description of the solution scenario so that we can explore how it's been put together. And really the key here is that applying these microbial nitrogen fixing biofertilizers is modeled as reducing the need for synthetic nitrogen fertilizers, in this case by 20% based on a study that came out in 2023. So in essence, what we've done for this solution scenario is just to reduce the need for synthetic nitrogen fertilizers by 20%, and that reduces these GHG emissions by 20% across the board. And that's how we've arrived at this solution scenario for our microbial nitrogen fixing biofertilizer. Okay, I'll leave you there. There's plenty more to explore in the solution scale, and you can see references and data sources in this datasheet tab that we haven't gotten to today.